not have imagined as reality 20 years ago. In fact, this project goes back a long time. It goes back to the 1960s when we were doing multi-step synthesis of various natural products, including the prostaglandins. And it was especially the work on prostaglandins that made me realize that the traditional way in which organic chemists built structures of complicated natural products had a severe defect. So traditionally, one would build up one of these complicated structures that have chirality, that is, it can exist in right and left-handed forms, starting in volume. So here's a very simple, the alpha-beta double bond. It makes it much more electron deficient. And because of that electron deficiency, this electron-rich diene, as this kind of high-voltage electronic system, this reacts much more rapidly in research. You never know where it's going to lead. Of course, it takes a little while for the discovery.
As well as the logic synthesis. And if there are questions, now we'll be
Yes.
Yes, hi. This is very nice and very clear explanation. One thing that I noticed was that the prostaglandin synthesis used the chlorobronitrile, and that gave the endo adduct, whereas the bromopropylene gave the exo with your catalyst. Is there a particular key to why that happens that way?
Yes, see if I can.
Kind of complicated question.
Acid. Then you cannot really expect, nor do you get very high enantiomer selectivity. Let's suppose you have a trace of some non-achiral Lewis acid species, or a different Lewis acid admixed with your catalyst. You're kind of wasting your time because it's not going to be a satisfactory result. So boron is easier to deal with than other things, but what element would you like to see there?
I like boron.
Boron is also a cheap element. We know how to make these cyclic boron compounds. So we would also like to study aluminum in the ring, and someday we might get around to that, I don't know. But it's a good question. There are other things that one can do. But those co-workers on that slide only were in my group 2 at a time, so it's not a huge group of people, and we tended to focus on boron. As is practical. I should tell you, too, my group runs on a shoestring. You would be amazed. I don't think we spend, our budget is less than $300,000 a year for everything. I don't use any federal money. I haven't used federal money. I haven't applied for federal money for almost 20 years. And the reason being that I think there's not enough federal money and I don't want to compete with young people. So it's a small group and there's a limited amount of stuff I can do. Yes?
Thank you for taking my questions. I was wondering what considerations go into the design of these catalysts that you design? Like, what are they thinking when you make these things?
Well, it uses, I hate to use the word, logic and knowledge of reaction pathways and structure reactivity. Uses all the insights that we have from physical, organic, the physical analysis of organic processes, knowledge of the precedented mechanistic pathways.
You mentioned that these catalysts are specific for specific substrates. So when you design these catalysts, do you have...
Sure.